Hello everyone. Today I will be solving another example related to Kirchhoff rules. In this circuit I have multiple batteries and connected with multiple resistors, and to find the current, as the question asking to find the current through each resistor, I must use Kirchhoff rules. Now, as usual, I will identify my junction, so I will pick the top junction. Then I will start distributing my current. So I will pick that current 1 will be in, the current 2 will be also in, which means the third current will be going out. So I'll distribute that all around. This one will be here, first current, here as well. For the side, the second current, and here I have the second current, right? As I did maybe in my previous video, I can, just to remind myself and secure the direction, where is the positive side and the negative side, or the positive potential and the negative potential side of each resistor. Here will be the positive, this one will be negative, and for this one here, that's the high voltage, that's the low voltage side. Here's the high voltage side, the low voltage side, and again this is the side where the current entering, and this is the side where the current exiting the resistor for, so I can tell which side is positive and which side is the negative. Now for the battery terminal, this is the obvious one, it's the positive, negative, and here we go. So this way I know where is my current being distributed and where is the high voltage and low voltage. From the first step, I can write my junction rule equation. Current 1 plus current 2 equal the third current. The total current going in equal the total current going out. So this is our first equation. Now the second step is to decide the loop direction or the travel direction. So for the left loop, I will go clockwise, and this is gonna be loop 1. For the right loop, I will go counter clockwise, and this is loop number 2. Okay, so let's write the loop equation or the voltage equation, which is the second rule of Kirchhoff. I will start from here and I will go up, then I'll fill the whole loop. That will give me a negative 5 current 1. Going through the first battery, that will give me positive 12 and minus. When I go through the second battery, I will have minus 3, and I'm going through resistor 2 with the current 3, that will give me minus 4 multiplied by the third current, and that's my loop closed. I just want to reorganize it again. So 12 minus 3, that will give me 9, minus 5i1 minus 4i3, and that will equal 0. That's our second equation. Now for the second loop, starting from this point, I could start from here and I will say, right, it's minus 3 multiplied by the second current. Okay, going through the resistor 4, it's going to give me minus 2 multiplied also by the second current. It's the same current still going through this branch, plus 18 volt, and now the middle branch, that will give me minus 3 volt, then minus 4 through resistor 2, current 3 equals 0. Once again, just to simplify things, because I have these 18 minus 3, and also I have these two terms from the same, like common with the current 2, that will give me 15 minus 5 multiplied by the second current, and minus 4 multiplied by the third current, and that's equal 0. Great. These are my 3 equations I need to solve or to find the current going through any resistor in this circuit. I have 3 unknown, current 1, 2, 3, and I have 3 equations. Okay, now what can I do is very simple. If I look carefully, I will notice something, that between equation 2 and equation 3, I have the current 3 is the common current between them. However, I also know that current 3 equal the combination of current 1 and current 2, which means I can use I1 plus I2 and replace it with the I3 in equation 2 and 3. Let's do this. So if I have from equation 2, here we go, equation 2, I have 9 minus 5 I1 minus 4, here, replacing I3 by I1 plus I2, and that will give me 0. Okay. Now I'm gonna expand the brackets and simplify my circuit. That will give me this. It will end with a 9 minus 9 multiplied with the first current minus 4 multiplied by the second current, and this is our new version of the second equation. I will name it star. Okay, just to keep everything in front of us for now. I can do the same thing for equation 3 here, and that will give me this. It's 15 minus 5 multiplied with the second current minus 4 multiplied with the combination I1 and I2 equal 0. Let's expand and simplify. That will give me this equation. 15 minus 9 multiplied with the second current is 4 multiplied with the first current, and that will equal 0. This is the new version of equation number 3. I will name it double star. Alright, so now if I look to these two equations, the single star and double star, I found that I have current 1, current 2, and current 1 and current 2 in each one of them. I can add them up and eliminate one of these unknown. So let's write them on top of each other and see how we're gonna do the elimination. All right, so I will have, it's 9 minus 9 I1 4 second current. Here I have 15 4. Of course, both equal 0. All right. Now, what am I gonna do? I need to add them, but before I do the adding, I'll have to decide which term I will be eliminating, or which current. So let's try to eliminate the second current. To do that, it's very simple. I could multiply the entire top equation with minus 9 and the bottom equation with multiplied with 4. If I look now, I will see that minus 9 multiplied with minus 4, that will give me positive 36 multiplied current 2. And at the bottom here, I will have 4 multiplied with a negative 9, that will give me negative 36, which means these two being eliminated. Now I'm just going to do the math. Minus 9 times 9, that's minus 81. We're going to add it to 60. It will give me minus 21. Same thing for the second term, and that will give me a positive 65, current 1, and all equals 0. Okay, that's a very simple equation now with one unknown, and that will make current 1 is 21 divided on 65. From here, current of the first current will be 0.32 ampere. That's the current 1, or the first current going through loop 1. Now what I can do is simply I'll take this value of the first current and place it on top of one of these two values to help me finding out uh, how much is the second term. So I'll pick the top one, which is 9 minus 9 here multiplied by 0.32, which is the equation, the single star. Okay, minus 4 I2 equals 0. You just do the math, and from here you will find that the second current will equal 1.53 ampere. So here we go. We found also the second current. Now we don't know from the junction rule equation. So if we go step back, the junction rule equation, first one, the summation of current 1 and current 2 should give me current 3. Okay, that's mean I3, it's I1 plus I2. You just add them up. It's 0.32 plus 1.53, and that will give you 1.85 ampere. That will be our value for the third current going through the circuit. Okay, this is the way to solve an example like this one related to Kirchhoff rules. As long as you distribute the current in a junction, know which one is in, which one is out, then if it's helpful, you could distribute where is the positive or the high voltage side from the resistor, where is the low potential side of the resistor. That's fine. It will help you when you do the loop equation to keep eyes on which term will be negative, which term will be positive, or which voltage on a certain element will be a positive voltage and which voltage on certain element will be negative, to secure your equation being written really well. Then you solve the math, right? I hope you find this example useful, and I'll see you with another one. Thank you.